Hello everyone, welcome to Linked Frequency. I'm Vaibhav Sugandhi, and in this particular tutorial I'm going to talk about how to integrate two actuators with Arduino development board. Integrating an actuator with Arduino development board is quite easy when you are understanding the process and protocol. However, we are going to talk about two different actuator integration with Arduino development board and creating a code for that. Without further delay, let's get started. Wonderful. So we are in front of a screen right now, and I will be showing you how exactly we are going to integrate two different actuators with Arduino development board. So let me hit that create circuit button now, and do remember guys, in this particular tutorial I'm going to use RGB LED and a piezo buzzer. Again, the reason is I want to make sure that you people understand the protocol, not just the circuit. Why? Because if I choose a complex actuator and try to integrate them, probably you will go out of a track and you will not understand the process of this integration process, or maybe integrating an actuator with Arduino development board. Because of which I'm going to use a very simple couple of actuator and going to show you how exactly you can create a code for that and simulate them. Okay, so right now I'm going to change this one to all, because we need to build a circuit first of all, and most important one, I need to change the name of this project. So integrating two actuators with Arduino, that's enough. Arduino board, that is not necessary. So just integrating two actuators with Arduino is sufficient. We need not hit that Control S again, and then we need to make sure that the component section is changed to all, so that we can access all the components available here. I'm going to scroll down a little bit. We have a sensor section, and then we have a output section, which is an actuator section. So here we have a RGB LED, and again after that we have NeoPixel LED strips and rings, a lot of them. I really don't know why they are so much available in this platform. Just for so creators, they have made it easy for them to do some activity here. I really don't know, but I'm not going to focus more on that. But my focus is on simple actuators, so that you can understand the process and you can create it by yourself. So piezo buzzer is available here, which is actuator which is going to convert your electrical signal into a sound energy, and there is RGB LED which is going to convert your electrical signal into a light energy. So I'm going to use couple of them, both of them, and I'm going to integrate them with Arduino development board and show you how exactly you can do it by yourself. Okay, so first of all I need to bring a breadboard for this. So breadboard, again this time I'm going to use breadboard small, so that I can have a good amount of space there to conduct my experiment. And scrolling a little bit down, we have RGB LED. I'm going to bring it and place it somewhere here, and then I need to scroll a little bit down, and then buzzer. So I'll place a buzzer somewhere here. Looks good. Okay, I'll just place it a little bit middle. Thereafter we need resistors, a couple of resistors here, 3 of them. So I'll place a resistor here. I use this slot for placing a resistor at this point of time, which is absolutely fine and really good one. Okay, so you can use this specific place for placing a resistor or ICs, all those things. Do remember, we have to change the value of these resistor to 470 ohm or maybe 100 ohm or something like that. So make sure that you change the 470 and then the SI unit as well. Okay, so we need to change it to ohm. Okay, by default it is in kilo ohm, so make sure that you change it to ohm. Thereafter we need to do it again for all the 3 resistor, remaining both of them. So I'm just going to do it now. Wonderful. 470. Great. So I think blue, green and red here, and cathode is open for us. I'll just drag a small Y here so that I can remember it as a cathode. Okay, that's great. Actually we are ready with RGB LED and piezo buzzer here. Most important, we need Arduino Uno development board, isn't it? So Arduino, so I'll place this Arduino Uno development below this time, because we need a GPIO access, and I believe it's quite easy to have a GPIO access at this point rather than keeping it on the other side. Okay, so I'll just make it a little bit here. Right now I need to create very important thing. I need to establish a ground connection here. Ground connection is very essential, so I'll just make a ground connection from this point. Oh, sorry, so I just cancel it. I'll do it once again. So I'll establish a ground connection from this point to maybe this point here, which is essential. Okay, thereafter we need to make sure that the cathode of RGB LED is connected to ground potential, and negative terminal of piezo buzzer is again necessarily need to be connected to cathode. Again, we have a two configuration here. When it comes to actuator, we have a two configuration. In sensors we spoke about two configuration, especially with potential push button actually, right? Active high configuration and active low configuration. I also spoke about a pull up resistor and pull down resistor, right? So we need to know about active low and active high configuration with respect to actuators as well. When you are using a high potential to turn on and low potential to turn off, like in direct sense, then you are using active high configuration, because to activate that particular actuator you are using a high potential. That is active high configuration, right? So in reverse or in a vice versa, we are using a low potential to turn on that particular actuator or to run that actuator, then we are using a active low configuration. Okay, so right now I would like to go with active low configuration in this push buzzer, so that it will have a certain advantage. If you want to create a little bit good impact of noise or sound that is generated from this push button, then you can go with the active low configuration. So right now active low configuration is all about connecting positive pin to VCC directly and using a negative pin with a GPIO, so that you can generate a signal or maybe a sound from this particular buzzer by sending a low signal, because VCC is already connected to positive pin, right? So that is how we do it. So I'll just use this connection. I use a yellow color here and I'll connect it to VCC. Okay, great. And I need to establish a VCC connection as well, so I'll use a 5 volt for this. So I'll be going like that. Oh, sorry. So I think we need to do it properly. I think I messed up, so let me do it once again. I'll go with this side. Wonderful, great. I think so I have connected it properly. Yeah, great. So I'll just make it a professionally looking good as well and change the color to red one. Okay, because it is VCC. Great. So now my buzzer positive pin is connected to VCC directly. Now negative pin, I would like to connect it to maybe I think I'll go with a green color for negative pin. Maybe I'll connect it to GPIO 3, I guess, because that is nearly available for me. 2 is also available, but I'm choosing a 3. I don't know why, but yeah, 3. So thereafter we need to go with RGB LED here. So 13th pin, I would like to use 13th pin for first color, which is maybe a green, I guess. No, it's not green, it's a red color. So I'll just make it looking professional as well and change the color to red. Again, don't confuse this red color with VCC potential. Of course it is not VCC potential, just indication of a color of this RGB LED particular pin. So it's a blue color. Second one is blue color, so I'm going to change it to blue color. And then we have a green color here at last, so I'm going to connect it to 11th pin of Arduino Uno development board. It takes a little patience to do it in a proper way, like looking good as well as professionally good and aesthetically looking good as well. So just make sure that you do it as much as possible best from your side. Okay, not necessarily need to copy the same way, but try to do it as much as best possible. Okay, so thereafter you need not to hit that Ctrl S because it is auto saved. I think pretty much we are done. We are done with RGB LED and a piezo buzzer. Now we need to jump to Arduino code Arduino IDE for developing a code. Again, I'm going to use a preprocessor directive, which is one of my favorite all the time. So first thing is RLED. Okay, RLED is connected to which pin? RLED is connected to 13th. So 13th pin here. Thereafter we need to go for GLED. Okay, hash define GLED. I hope it's a B LED, the next one. So thereafter I need to go for G LED, which is last LED. I think I forgot my keyboard in home today. Because of that, I'm not able to type it properly in my laptop keyboard, but that's okay. I enjoy the process both the way. So buzzer is connected to which GPIO? Third GPIO. So I'm going to use 3 here because it is connected to third pin. Thereafter, what we need to do is we need to clean up this one. I'll remove these comments. Of course, I'm not writing a comment in the entire process of this whole tutorial. By the way, from beginning to end, I'm not going to write any comment. Why? Because I don't want to make it complicated for those people who are learning it for the first time. That's why the name of this course is Absolute Beginners. I mean, Arduino development course or Arduino course for absolute beginners. Okay, so in setup, what we need to do is we need to configure them. So what I'm going to do is pin mode, and so I'm going to use RLED directly, because that's what the role of preprocessor directive. And of course they are output. Why? Because they are all actuator. There is no question on that. And now I think I can use my shortcuts, which is like this. That's my favorite. So B LED, and then we have G LED, and then buzzer also. Again, buzzer is also output one. So BUZZER buzzer, and then again we need if we need serial monitor, we are going to use a serial monitor. Otherwise no. For this particular application or maybe project, I'm not going to use a serial monitor. Just make it even more simple for you to understand it. Okay, so what we need to do is we need to understand the algorithm first. What we want from this entire project, whether we are doing it purposefully or not, I don't know, but you have to understand the requirement first, and based on that you have to create your code or organize your code in such a way that you should achieve your end result, right? Achieve your result, not end result. Okay, so do remember that one. Right now I'm going to create a hypothetical situation where I'm going to write a code based on that. First I want to turn on red LED and then create a small beep on the buzzer. For what reason I really don't know, but just creating a hypothetical situation. Okay, so red LED and then a small beep on the buzzer, and then green LED blinking 2 times, and then a small beep on the buzzer, and then blue LED blinking 3 times, then a small beep on the buzzer, and then all 3 LEDs are turning on, which is a white color, combination of all 3, which is going to create a white color, and then beeping a buzzer 2 times. Looks very complicated, right? But that's what we need to learn in this process, right? So I mean, we need to learn that. That's why we are creating this whole tutorial. So first of all, what I'm going to do is I'm going to create a digital write, which is a very important one. So what I said is I need to start with the red LED. So R LED, I'm going to send a high signal to it. Do remember it is active high actuator, or maybe you can say to turn on that particular LED you have to send a high signal, because of which we connected cathode pin to ground. I hope you remember this one, right? So cathode pin is connected to ground, so whenever you send a high signal here, a red LED turns on. That's what we did in the previous tutorial either. Okay, so right now I'm going to send a high signal to R LED, and then turn on R LED and create a small beep on buzzer. So digital, if I'm changing algorithm little bit in between, please don't mind, because I can't remember that complex thought process I created by myself. So I'm going to create a beep here. So I'm going to use a buzzer, and now comes the very important point. Do I need to write a high here or low here? Yes, answer is low. Why? Because we are using active low actuator. I mean, we configured it in such a way that to turn on that buzzer or to create a buzz sound from that buzzer, we have to send a low signal, or we have to make that particular GPIO as a low. But what happens when we configure this one? When we are configuring, by default that particular GPIO is kept as low by this microcontroller. Okay, so what we need to do is we need to correct that. Otherwise what happens, the moment when this entire project turns on, you can start hearing that buzzer sound, which is irritating most of the time. For that reason, I'm going to add a digital write buzzer immediate after initialization. We need to do this one, otherwise we we start hearing that buzzer noise immediate after turning on the power, okay, or maybe pressing a reset. So we just want to execute this specific instruction only once after configuration. That's why I am writing this instruction in setup. This is what the learning of this entire tutorial. So do remember, focus now. So this is the first instruction which I want to execute immediate after configuring the buzzer as an output pin, or as a GPIO as output. Okay, so because of that, because of which we can make sure that the buzzer is not turned on by default. When you want to turn it on, you have to send a contradictory signal that you have written here, of course, right? So that signal is all about the low. The moment when I send a low, it will start buzzing, and I'll wait for say 500 millisecond, which is sufficient enough to hear that particular sound. Thereafter I'll write high signal to that buzzer comma high signal, which will turn off the buzzer. Do remember, don't confuse yourself. Sending a low to buzzer GPIO or maybe a buzzer will turn it on, and sending high will turn it off. Why? Because we have created a circuit in such a way that it will be configured in active low configuration. If you would have connected it in a normal way, how we used to do it in general cases, then it is going to be a normal way. But right now we did it in different way. That's why we are having a different code for that as well. So thereafter, after red LED turned on, we create a one beep. And then we have to turn off the red LED. Don't leave it hanging there, okay? So you have to turn it off by sending a low signal to that particular RLED GPIO. So I'm going to do that right now, and then wait for certain time, because user want to feel the difference between one particular action or maybe one particular task to another task. So I'll wait for 1 second here, which is sufficient time to feel the proper delay. So thereafter I'm going to use my shortcut, copy and paste. Instead of RLED, I'm going to write a BLED, turning on BLED and turning off BLED, but in between we need to make sure that 2 times a buzzer will beep. That is what I said, right? So here we need to add an extra delay to differentiate between off and on condition of buzzer. Otherwise what happens, it will beep in a longer duration for a short period of time. So I'll just create a 500 millisecond delay here, and then I'll paste my code, whichever I copied from the top. Okay, so BLED will turn on and buzzer will turn on. Wait for 500 millisecond, and then buzzer will turn off. Again wait for 500 millisecond, and again buzzer will turn on. Wait for 500 millisecond, and then it will turn off. Okay, so by doing so, you are creating a 2 beeps on buzzer. Okay, so that's how you are going to write the code. This is what we wanted to learn. Again, I'm coding it again and again. Do remember, it's all about identifying how to organize the instructions. I think for this particular tutorial, this is enough. I don't want to drag it even more. It is already too much, and I believe you guys can understand this one. Again, I'm going to add a little bit of delay here, which is a delay of 1000 millisecond, so that you can differentiate between this particular task and this particular task, okay, which is this one. Okay, so after this, what we need to do is we need to copy the code and go back to Tinkercad. Hit on that code section, change the block to text, hit that continue, copy the entire code, paste it here, and just we need not hit that Ctrl S again. Okay, so just cross verify whether buzzer is connected to 3rd pin, 13, 12, 11 is for RGB LED. Okay, wonderful, looks wonderful to me. I'll just hit that start simulation button there. Can you see this one? Of course you can't hear that sound, I believe, because I have connected a microphone here, so just to avoid some disturbance. Can you hear this one? When RLED is turned on, only buzzer is turning on 1 time. When BLED turned on, the buzzer is beeping 2 times. That's exactly what we wanted, and that is how we organize the code here. I hope you understood this one, and I believe you're going to try it by yourself. Give a try. Let me know your thoughts in the comment section. Wonderful. Thank you so much for watching this entire tutorial, and I hope you enjoyed it and you're going to try different things with this Tinkercad platform and Arduino Uno development board. Consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.